finishing 7.2. The plan is to finish 7.2 and 7.3. I don't know if we're going to get 7.4 done. Probably not. Probably just those two we'll be due on Monday. We'll see how we do. But I'm guessing 7.2 and 7.3, that's it for Monday. We're getting close, aren't we? Our practice exam is next Wednesday. So we're getting close to wrapping up the material for the big bad exam number 4. So practice exam number 4 next Wednesday. Now remember, I don't want this one to take you by surprise. Remember, that's like my whole teaching philosophy. I aim not to surprise, right? So don't be surprised. Exam 4 is harder. I don't mean I'm going to do any tricks or anything weird. I just mean the material's been harder. And I mean year after year when I give that exam, the average drops like 2 whole grades. It's dramatic. Yeah, I'm not just saying this because it's a small thing. It's way harder. The average, like, what has been our average? I don't know, average probably 75, something like that on the last exam, 78, I don't know. The average will drop to 58. It will. Now, I mean, that'd be great if it did, and you guys have been a pretty solid group so far, so maybe it won't drop that far. But just because the average person drops doesn't mean you need to. So I'm not wanting to discourage you with this. I'm wanting to encourage you, but to let you know what you're up against. This exam is tough. The material is just messier. It's just messier business. All the stuff we've been doing, do we have logs? Am I getting confused? That's the next exam. All right, I'm teaching pre-calc right now. We're doing logs all the time. I forget. We're not doing. We will soon be doing logs in here as well. Anyway, there's others. Whatever it is we did, it must be hard stuff because the average is always lower. So study hard. So what I'm saying, I hope you hear that and you think the following thought. I'm going to study harder than I normally do. At least if you want to keep the same grade. If you're happy with whatever grade you're hitting at, A level, B level, whatever, you're going to have to put more into this one to keep that grade level. If you just do the same thing you've always done, you will drop 2 grades. That's what the average will do. The average will drop 2 grades. So if you're okay with dropping 2 grades, just do the same thing you've always done. If you don't want to drop 2 grades, change something. Work harder on the practice exam. Make sure you know every detail. Go back over the homework and make sure you can do every single problem. Come to my office hours, come to Roberto or whoever else. Make sure you can master the material. All right, enough said. What's that?
We didn't finish number 3.
We didn't finish number 3.
We started it and then you were like...
Okay, I'm just going to move on with number 4 anyway, but thank you. I'll move on because they're all kind of the same thing. So first thing on this one is just a bunch of distribution and gathering like terms and all that kind of stuff. So boom and a boom. So 12x minus 48. 12x minus 40. And then this minus, boom, boom, right? Whenever you have a minus sign in front of parentheses or a number in front of parentheses, it distributes, as you know. Minus x minus 2. Other side, we got a FOIL. X squared minus 4x, boom, boom, plus 2x minus 8. Good to there so far. And then now let's just gather like terms. 12x minus 1x is 11x. Minus 48 minus 2 is minus 50. Minus 4x plus 2x is minus 2x. We good so far? Now what should we do? Yeah, you know the game plan, the sea monsters here, x squared. It's still the basic same game plan. When we see x squared, we're going to what? Get a 0, huh? Always get a 0 on the opposite. In fact, if you want, I could write out the game plan. It's the same game plan as always, except now we have the quadratic formula as kind of a last resort. If the normal method won't work, you can always do the quadratic formula. So the game plan for x squared with equals now just has one extra step. Step 1 is always get a 0. Step 2 is, now I'll say try to factor, because now we realize not everything actually factors. And step 3, if it won't factor, then you use the negative b plus or minus square root of b squared minus 4ac all over 2a. It's kind of a last resort if it won't factor. Okay, so we see x squared, we still think the same thought, get a 0. How do I get a 0? I make the other side 0. So subtract 11x, add 50. Subtract 11x, add 50. Boom, boom, 0. What's that, 42? Good so far? Good to there. Now, I would try to factor that, because factoring is easier than the quad. I mean, you could do the quad. If you want to just jump right into the negative b plus or minus thing, that'll always work. You can always do that. But if they factor, if they're easy factoring, then that usually is a little quicker. So it's whichever you prefer. I can see this one factors real nice and easy. See how it does there? Yeah, what multiplies to be 42 and positive 42 and adds, remember the middle is always the add, right? What multiplies to be 42 and adds to be 13? What times what's 42? 6 and 7, huh? 6 and 7. And what signs do they need so that they'll add to be negative 13? Both negative, huh? Right? Negative 6 and negative 7 is negative 13, and they two negatives multiply to be positive. So that's quick and easy. And then remember what you do from there? Remember how each one gets their own 0? Because if two things times to be 0, either one could be 0 to make them times and be 0. Because 0 times anything is 0. Right? So that means then just jump it over, jump it over. It's just going to be opposite sign, huh? Positive 6, positive 7, done. Now, if you did the negative b thing, you would get the same two answers. It's just more work. So I'm in the quadratic formula section. I didn't actually do the quadratic formula because it was easier just to factor. Is that good? Everybody okay with that? So we've done stuff like that before, huh? So just get a 0 factor. Now, if it was not able to be factored, then I would have done the quad. You'll see. We'll see as we... Okay, so try that one. X squared plus 26 is 2x. So when you see x squared, what's the first step? Get a 0. Get a 0. So just jump that 2x, right? You always get 0 on the opposite side from x squared. So jump that 2x over. It becomes a minus 2x. You put it in the middle, right? Because they have to go in order. X squared, x, no x. Right? So always x squared, x, no x in order. And the 2x is negative now because it jumped to the other side of the equal sign. Good. Okay, so now you can try, look here, watch, I'll try. If you try to factor this, it won't work. What multiplies to be 26 and adds to be 2? Nothing. I mean, what times what's 26? 2 and 13, that's all I can think of. And that certainly doesn't add to be negative 2, does it? See how it just doesn't factor? This can't factor. So if they don't factor, if you give it a try, because that would be quicker, if that works. But most of them aren't going to be able to be factored. And so what do you do when they don't factor? The quad. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the new thing in this section. This is what we do when they won't factor. So plug everything in. What's the a? Yeah, the a is what's in front of the first one. The b is the negative 2. The c is the 26. A, B, C. 1, negative 2.
1.
What's that?
A is going to be 1, right?
A is 1.
The coefficient is.
That's right. So A is 1, B is negative 2, C is 26. So the A, B, and C do not include the x's. It's just the numbers in front of the x's, right? Just peel them off. So plug them in to the quad.
Negative b is going to be negative 1 times negative 2. Because it's negative b.
Yes.
Since there's already a negative in front of the
B, yeah. Turn to positive. Yeah, totally. Good. So everybody dialing in? It's going to be, you guys are right that are saying that. It's negative from the formula, and then there's like also negative on the B, so it's going to end up positive 2 out there, isn't it? So it's negative B, and B is negative 2, so it's negative, negative 2, positive 2, right? B squared minus 4 times A times C all over 2A. Like that? Good. Just crank out the numbers. So 2 negatives make positive 2. positive 2 plus or minus the square root of 4 minus some, oh, it's going to be imaginary, isn't it?
Yeah.
52 is that 104? So that's going to be 2 plus or minus square root of negative 100. What do you do with negative 100 inside? What do you do with a negative in a root? Out comes an I. It's imaginary. It's not real. It's just in our imagination. So grab that negative and you put an I right in the front of the root. Doesn't go past anything else. That negative just comes out, an I right there in front of the root, huh? That's what we always do with a negative in a root. Everybody good with that? Just turn it into an imaginary right in front. So then that's 2 plus or minus I. And what's the square root of 100? 10. So that's square root of 100. After you get rid of the negative, then you can do the square root of 100 is 10. Last step. Am I racing ahead of you? Can I reduce this? Can I cancel those 2's? It's because of the glue, it's all 3 or nothing, and I can do all 3. Good on that? So yeah, you divide all 3 of them by 2. It's going to become 1, 5, and 1. Divide all 3 of them by 2. Remember, at the very end, when you have the glue, it's all, right, they're glued together, Costco, buy the whole package or nothing. So it's all 3. You look at all 3 of these guys, and you say, are all 3 of them divisible by the same number? Yes, they're all divisible by 2. If any one of them was not, like say this is a 9 or something, then I would just stop. I couldn't do anything. It's all 3 or nothing, right? That's the Costco rule, and we obey Costco. So divide by 2, divide by 2, divide by 2 leaves a 1, leaves a 5, leaves a 1. Like that. Is that good?
So 1 plus or minus 5i?
So the answer is 1 plus or minus I times 5 over 1. And the ones on the bottom we ignore, huh? Yeah, we don't need ones on the bottom. So there it is. There's our 2 answers. That's really 2 answers. 1 plus I. And if it bugs you, you can put the I in the back of that. Kind of bugs me a little bit. It doesn't matter though. Math will take it either way.
Isn't the square root of 2 negative 4?
Isn't the square root of?
Or the.
Oh, the square root of 4 here.
Yeah. So wouldn't it be negative 4? Because how you got the negative.
Well, right here it's 2 power, so that means negative 2 times negative 2 is positive 4.
Got it.
Is that good? Other questions on that one? All is well? All right. Let's keep moving. Bring in some old problems, basically, is what they're going to do. So this is like an old situation here. All right, so what do you do with, that's like a flash from the past there. That was our last exam. Remember the one with all the fractions? Mm-hmm. So how do you solve a fraction equation thing? What do you do?
Fractions times x and 15 on the home.
Yep, exactly. 15x, top, huh? Remember that? You just look at the denominators, which are 15 and x, and you just say, everybody gets one, top. Very good. You guys are learning algebra. That makes me happy. At least Ajane is. Everybody else learning algebra too?
Yeah.
Good. 15x. Exactly right. That's what we do with fractions, huh? Common denominator, top. And then cancel. Don't forget to cancel. Good. It's good review. That final exam's coming in a few weeks, 5 weeks, 6 weeks, something like that. Which will have everything on it. What do we got? 1, 2, 3, 4, 5, 6 weeks. 7 weeks. So cancel. Oh wait, no. Whoops. Can't do that. That x is not a denominator, is it? That they're both over 1. That was a mistake I just did. Try that again. That was x and 50. So they're going to multiply be 15x squared, aren't they? Actually, these guys will cancel because you only cancel stuff that's under the bar with stuff above, right? It's kind of good. I made that mistake, so you won't. Did it too, huh? 15's cancel. 34x. That makes sense then? So only stuff under the bar cancels. If you're going too quick, you might, like I was, you might accidentally do that. Good to there. And now what?
Move the 34.
Yeah, x squared, the sea monster's reared his ugly head. You know what to do. Get a 0. Get a 0. And you can try to factor. I'd probably just go right to the quad. This one's hard. Even if it does factor, whatever. I just throw it into the negative b, plus or minus. Just crank it out. Be easier than messing around with factoring, I think. It's a minus 34 when you bring it over, right? Minus 34x. Put it in the middle. Keep the order right. So plug into your friend the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So use your calculator. These are big, ugly numbers.
I don't have a plus or minus button on the calculator.
Got the same trick with the double negative on the b. It's going to be positive, right? Grab A, B, and C, plug them in. So, what do we got? So 34 plus or minus. Kind of messy here. So what's 34 squared?
I got 1156.
That is 1156, thank you. Oops. 1156 minus 66. Is it 900 over 30? Messy. So then it's 34 plus or minus 256. Well, that's 16 if you root it, huh? Y'all getting to there okay?
My calculator kicked out 7 or 19.
I think 256 is going to be 16. So that's 34 plus or minus 16 over 30. Good there. And so what do? You have to actually do, there's no more root left. Yeah, so I should probably explain. Everybody good there? I'll go to a fresh screen. So everybody got that copied down? So the root of 256 just turns into 16, huh? Right? So let me write that over here. So 34, I'll go back a step, plus or minus root 256 over 30. Yeah, 30. Okay, so when you do that root, you get 16. The root vanishes, doesn't it? Because that's a perfectly rootable number. It comes out real clean. Let me write a note for you. When the root vanishes, we must write two answers and finish. So in other words, we've got to go, bring it over to here, we got to go 34 plus 16 over 30, or 34 minus. You got to actually separate. Now you might wonder why. We never did that before. The reason we have to is because we don't have a root now. What do I mean? Well, if there was a root, think with me for a second. If there was still a root here, if this was like, let's say 16 root 3, and I still had like an extra root hanging around, I'm done. I'm not going to go any further. Because, why? Well, because you can't add. There'd be no point in like writing 34 plus 16 root 3. You can't add them. They're unlike terms. One's got a root, the other doesn't. They're unlike. They're not going to add. They're not going to subtract. But if the roots all vanish, well, yeah, I can just simply add 34 and 16. They're just plain numbers now. And I can subtract them, so we need to do that. Do you see the difference? When the roots vanish, you got to go ahead and add them and subtract them, because now they're just plain numbers. They're like terms. There's no more roots making them unlike. So what's that going to be then? 50 over 30, which reduces to be 5/3. And this one is, I don't know, what is it? 18? Thank you. 18 over 30. Reduce that thing, divide by 6. 3/5. It's funny. 5/3 and 3/5. There's the two answers. They want both answers with a comma. Everybody see what happened? You see the difference when you're doing the quad formula and the root is clean, the root vanishes, then you got to finish it up, because they can add and subtract. They're just plain numbers at that point. We don't leave it. All well? Questions? All right. Don't want to do too many. I want to get into the next section, which is a challenging section. But do maybe one or two more of these fraction ones and move on. 1 over x plus 3, 1 over 2. Let me let you do it. You know how to handle fractions, right? Common denominator, top, right? And what is the common denominator?
X times 2 times x plus 3.
It's everything, huh? You need the 2, the solo x, and the x plus 3 package. It's everything. They're all right. They're all there. 2x x plus 3. 2x x plus 3. 2x x plus 3. Everything. Top, right? And then cancel whatever you can and multiply what's left over. X cancels x, and we have 2x plus 3. X plus 3 cancels x plus 3. 2x, 2 cancels 2. So everybody good to there? Does that make sense after the canceling? So now we got rid of all the fractions, no more fractions? Much nicer? Then distribute. 2x plus 6. Boom, boom. X squared plus 3x. We good? Yeah, and then you know the game plan. Gather like terms and get a 0. The sea monster is on the scene. Get a 0. So 2x and 2x, 4x plus 6. So make that left side become 0 by doing the opposite. Boom, boom. Yeah. And then I think that one's factorable, huh? You can just factor that thing. 2 parentheses, you don't have to mess with the quad. the negative b plus or minus. Just factor that thing. That one's quickly, easily factorable, so we can save some time. Don't have to do the negative b plus or minus stuff. Julio's the factoring man, huh? All right, so what numbers multiply to be 6 and add to be -1? Yeah, 3 and 2. And how do the signs go? Sign in the middle goes to the bigger number, goes to the 3. So -3 plus 2, huh? -3 plus 2 is minus on the middle. Negative times positive is -6 at the back. And then you know the answers are just opposite sign, huh? So it's just going to be +3 minus 2. It's kind of scribbly. Let me try that again. +3 and -2 are the final answers. Just opposite. Is that good?
You have to plug those in and check them?
No, not required. Don't need to check them. The only time I know it's kind of like when we checked a while. You only check things that begin with roots. I'll say that again before. Or that was the last exam, wasn't it? Was that last exam? Was this exam? Oh, it is this exam, yeah. I'll mention it on practice exam day. Yeah, it's only problems that begin with roots. All right, we good with that? So these don't need to be checked. There's no roots in the beginning here. That good? All right. Okay, so 5x squared minus 5x minus 7 equals 0. So I would just dump it right into the quad. I wouldn't even, you can try to factor, that's not going to factor. I would just go right into the quad, the negative b plus or minus. It's ready to go. It's already got the 0 and everything, huh? So negative b plus or minus the square root of b squared minus 4ac all over 2a. Like that. So a is 5, b is -5, c is -7, a, b, c. Plug those in. Okay, so negative, and b is itself negative, so we got the double negative trick again. B squared minus 4 times a times c all over 2a. That's 5 plus or minus square root of 20. Watch the signs here. Just, you know, when it comes to the sign, you got negative, positive, negative. So that's 2 negatives. It's going to be positive, whatever your calculator tells you it is. Right? So just count the negatives. If there's 2 negatives, it's positive, right? And then just multiply your calculator, it's going to be 140, right?
Yeah.
On that over 10. Good. So watch out for the sign. That's a place sometimes people get tripped up. Okay, so let me bring it up here. So we get 5 plus or minus the square root of 165 over 10. Now, does that 165 break down? I don't know, it might. I know 5 goes in. I'm going to have to check it. So take 165 on the side. Remember about that? Divide by 5. Is it?
No, it doesn't break down anything.
What is it? Divide by 5 would be 30.
3.
What is 33, 150, and 50? Yeah, 33, and that's 3 times 11. So there's no pairs in there. So yeah, we just leave it 165. I had to check though to be sure. Does everybody see what that means? Right? I broke down the 165, and I found out 5, 3, and 11. So there's not 2 of anything. Nothing's coming out of the root. So just leave it, root of 165. So that's the exact answer which they're asking for. But then on part 2, they also want the calculator answer. So you guys have your calculator with you? We're going to need to give 2 calculator answers. Which 2? Well, the plus version and the minus version. So 5 plus root 165 over 10. And 5 minus root 165 over 10. So on your calculator, the first one, I don't know what it should be, so like 10, 11, 12, so 12, 13, 12, 17 over 10. It's going to be 1.7 or 8. What is it,
1.785.
785. How many places? 3 places? Yeah, 3 places.
Rounded to the nearest thousand.
Okay, 1.7. What was it before you rounded? 1.78?
1.78, 4, and then the next one was a
4, 5?
yeah.
Yeah, so good job. So you rounded right. So everybody know, I just want to remind you about rounding. Right, they said 3 places, so circle the third place, look 1 to the right, so 1.785 is correct. And the other one is negative something or other.
Yeah, it's going to be negative 0.785.
70, so rounds to 75.
Yeah.
Negative 0.7. You able to get those 2 on your calculator? 1.785 and negative 0.785. It's what?
Yeah, 0.785.
Right. So you know the 0 in the front's irrelevant.
It just looked like that at 1.
So this one's 1.785.
Yeah.
This one's negative 0.75.
Yeah.
All good? Question, you guys able to do that on your calculator? If you're having trouble getting that, feel free to grab me after class. In the meantime, if you try with a friend nearby or something. One thing that might help, it depends, they're all a little different. That's the reason I can't just say one thing and help everybody. You might need to hit equals at the end. That's something that gets people sometimes, at the end of the numerator, I mean. When you finish the numerator, make sure you hit equals, then it does the whole numerator, and then when you divide, it divides the whole thing. Otherwise, if you don't hit equals, it'll only divide the last number. At least that's on the old calculators. The new ones that show a fraction, they're great. You don't need to mess, they just do it right every
I
time.
love my Casio natural.
But if you have the older ones, you might need to hit equals at the end of the numerator. That fix it? That good? We all good? So grab me after 10 seconds. I can help you with that. But those are on the test as well, so make sure you can calculate them. 1.785 and negative 0.785. And that also. They want all 3. They want the exact, and then they want these 2 decimals.
Well, you want the exact and the decimal as well?
Yep, see there, right here they're saying, give me the exact. That would be this.
On the test.
Yeah, I could go both ways. I won't give them all at once, but one problem might be exact, another one might be decimals. Yeah.
You're killing me.
That's my aim. Number 12 here. All right. Square roots. Do you know what that means? This problem is going to need to be checked in the end. So again, I'll remind you on practice exam day. But here it is. Any problem if it starts with, if it starts with a root, check at the end. That's where you can get like the false answers, Any problem beginning with a root, you might get faulty answers at the end. And it would be a bummer to do a bunch of good work then on a multiple choice question, end up grabbing the one that doesn't, just because you didn't check.
With this one, we're just going to square both sides, right?
Exactly. Yeah. Remember the steps for roots. Step 1 is get the root alone. It already is alone. Number 2 is 2 power both sides, right? And then step 3 is check. Remember those steps? Whenever you see a root, you got to get it alone. It is alone. I mean, like if there was like a plus 10 out there or something, I would get rid of it. But there's not. It's alone. So just go ahead and 2 power both sides. Parenthesis 2 power, parenthesis 2 power. 2 power both sides. Solve it, and in the end, check. So 2 power both sides. And remember, the root and the 2 power cancel each other, don't they? They're opposites. So you get 7x
Ooh, but it factors.
plus 36. Other side, x plus 4. You got to write 2. And x plus 4 is when there's a 2 on a parenthesis, you got to write 2 of them, right? So there. And then FOIL this side. We get to there. Four x and 4x is 8x. Very good. And now what do we do at this point? Sea monster has reared its ugly head. Get a 0. On the opposite side from x squared, huh? X squared's on the right side, get the left side to be 0. So subtract 7x, subtract 36. Whatever you do to one side, you got to do the same thing to the other to keep the balance. Gonzo gonzo. 0 is x squared plus x. What's that, minus 20? And that, you can factor that, huh?
You can, 4 and 5.
Yeah, just factor it 4 and 5. Be careful on the signs, and then you'll have your answers.
Positive 5, negative 4.
So we don't have to mess around with the negative b plus or minus stuff. Oops. So 5 times 4, 4 times 5. 4 times 5 is 20.
Positive 4, negative 5.
Yeah, sign in the middle goes on the bigger, doesn't it? Plus 5 minus 4 makes plus 1 in the middle. Multiplies to be negative 20. And so it's just opposite. So positive 4 and negative are just opposite signs. There's our answers. Plus 4 and negative. Oh, maybe we got to check them, don't we? I almost forgot. We got to check them. Maybe one of them's bad.
Because 5 doesn't work.
In fact, the negative 5 won't work. You're right. Let's check them. So I'm going to go to a fresh screen and check them. If you're running out of time on the next test, you only have seconds. Usually the negative one's bad. Now that doesn't always work. They could do a real trick where that doesn't happen, but most of the time the negative one's bad, or the lower one. If you have like a 10 and a 2, both positive, the 2's probably bad. Usually the lower one's bad. Not always. They could both be good, both be bad. All different things can happen. But usually, and if you have no time left, you should be expecting, I bet that negative 5 is bad and that 4 is good. That's usually the way these root ones go. Let's check it. So what number is this? Number 12. Okay, so number 12. I'm going to check the first answer, which was x equals positive 4. That one will be good. And then over here I'll check x equals negative 5. So where do you check? First step, huh? Go back to that first step before you did anything. So square root of 7x plus 36 equals x plus 4.
Is it regular 5 and negative 4 were the answers? Or was it the other way around?
Nope. Nope. Check your signs on that. All right. So let's check this one. So plug in the 4 right there. So we get 7 times 4 plus 36, and plug in the 4 right there. Does that equal 4 plus 4? 28, 58, 59, 64.
When we factored it,
8.
negative 5.
I can check with you later. And then do this one. So the other side, let's see, what do we got right there? 7x plus 36, x plus 4. Plug in the negative 5. See, it's not going to work. See, this side's negative 1. No way a square root's going to equal negative 1. Do y'all see that? Square roots come out positive. You can't have a negative coming out of a root. So I don't even need to go further. I know it's not going to work, but I'll go on anyway. That'd be negative 35 plus 36 in a root. That's how I knew right away when I looked at it it wasn't going to work. Square root of 1 doesn't equal negative 1. It's positive 1. That's not true. Right? Square root of 1's positive 1. It's not negative 1. So that's not true. No. So that answer's no good. The only answer is the 4.
Now put it into Math Excel and see if it accepts it.
So are you doubting me? I'm never wrong, except for when I'm wrong.
Yeah, what did
Okay.
I do wrong?
Yeah, I can check with you later. Look at 14. Square root of x plus 7 is negative 1. What should we do with that problem?
No solution.
Why so?
Because a square can't come out to a negative.
Beautiful, Julio. You should bubble no solution and move to the next question. How could that be true? Think with me. Maybe plug it in will help. Pick any number you want. Put in a 2. That's nice. I'll make it 9, right? Square root of 9 is positive 3. How can any square root equal negative? It can't. There's no x value that can make that true. Right? Now you might think, well, yeah, just make it negative. Put in negative 8. That'll make it negative 1. Well, that'll make it imaginary is what that'll do. You put in negative 8, that'll be the square root of negative 1. That's not negative 1. That's imaginary. That's I. There's no way a square root can equal negative. Remember, negatives in a root are imaginary. No solution. That's how I knew, by the way, right away, that the negative, when I got the two answers here, I knew the negative 5 was no good right away. Because negative 5 on this right side was going to make that right side negative 1. I knew the root couldn't equal negative 1. That's all I had to do to know right away. So roots can't equal negative, can they? There's no way. So, good. So just do that. Save time. You're done. But number 14. Okay, so cube root of x plus 4 is 6. So we got to get rid of that root, huh?
So cube it?
Third power, huh?
Yeah.
Yep, that's it. Go ahead and do that. Third power on both sides. So not times 3, third power, right?
Yeah.
That's different. Third power both sides, not times 3. So third power. So the third power cancels the third root. And 6 to the third power, that means 6 times 6 times 6, doesn't it? 216? Mm-hmm. 216. How do you finish solving for x? Subtract 4. So that's 212. Done. Do we need to check it? No, actually not. It's guaranteed to be right. Why so? I thought I said roots need to be checked. Well, I wasn't really telling you the whole story. I'm always sort of half lying to you. It's just because I don't want to give you too many details. Really, only even-powered roots need to be checked. We hadn't had odd-powered roots up to now. I don't want to bore you with a lot of details. Let's just say do not need to check odd roots, like third root. You don't need to check that. Why not? Why not? Because they don't have a problem with negatives. It's the even roots that have a problem with negative. I don't know if you've ever stayed up late at night and thought about that difference. You know what I mean? Like, what's the square root of negative 4? What's the 2 root? What times itself twice is negative 4? Nothing. You can't have something times itself negative, but you can do the cube root of negative 8. Negatives in a third root are fine. What times itself 3 times is negative 8? Negative 2 times negative 2 times, because an odd number of negatives is negative. That works fine. Negative 2 times negative 2 times negative 2 is negative 8. It's great. It's not a problem, is it? You can have an odd root negative, but you can't have an even. You can't have 2 things come out negative, can you? Well, that didn't say that very well. You can't have the same thing twice come out negative, but you can have the same thing 3 times come out negative. You see the difference? So long story short, you don't need to check odd roots. They're good. They're guaranteed. Method's reliable. It's only the 2 roots that are the problem that we have to always be checking.
Okay.
All right. Are we good?